Assalamu alaikum wa rahmatullah. Today's topic is the general histology of the respiratory system. The respiratory system, the complex of organs and tissue which are necessary to exchange blood, carbon dioxide, and air oxygen. It's called the respiratory system. It consists of two structures which function as ducts and which together are called the conductive portion of the respiratory system, and another structure which is the respiratory portion of the respiratory system, in which the exchange of the CO2 and O2 is occurred, and the part of the thoracic musculoskeletal apparatus and the specialization of the lungs, which allow the movement of the air through the respiratory system, is the ventilating mechanism. Nasal cavity. The nasal cavity is divided into three structurally and functionally divided parts, which is the vestibule. The first 1.5 centimeter of the conductive portion following the nostrils are lined with a keratinized stratified squamous epithelium, which filter larger particle matter of the air stream, and spacious glands are also present. At the transition from the vestibule to the respiratory region of the nasal cavity, the epithelium becomes first stratified squamous and then pseudostratified columnar and ciliated. This type of epithelium is characteristic for all conductive passages dedicated to the respiratory system, and therefore also called respiratory epithelium. Mucus-producing goblet cells are present in the epithelium, and the surface of the lateral part of the nasal cavity is thrown into folds by bony projection called concha. These folds increase the surface area of the nasal cavity and create turbulence in the stream of passing air, which facilitated to condition which is the warming and cooling and filtration of the air. The mucus and serous gland in the connective tissue underlying the epithelium and the lamina propria supplement the secretion of the goblet cells. Veins in the lamina propria form thin-walled cavernous sinusoid, also called the cavernous bodies. Tissues on the superior concha and the nasal septum form the olfactory region of the nasal cavity. Cilia in this epithelium is called the olfactory region, arising from the olfactory cells. Although their internal structure resembles largely that normal cilia, they do not move because the lack of dynein arm, which are necessary for cilia mobility. The cell membrane covering the surface of the cilia contain olfactory receptors which are respond to odor producing substance and odorants dissolving the serous covering epithelium. The axon of the olfactory cells collect into bundles in the lamina propria. The olfactory cells and their processes receive the mechanism and the metabolic support for supporting cell, and basal cell can divide and differentiate into either olfactory or supporting cell. The supporting cell and the secretion of the serous gland contain lipofuscin granules which give yellow-brown color to the surface of the olfactory region. As we see in this region, in this figure, we have the olfactory region and we have the cells of the olfactory region and the histology of it. Now we move to the pharynx. The pharynx is connected the nasal cavity with the larynx, and it depends on the external absorptive force of the epithelium. The pharynx is either lined with respiratory epithelium, nasopharynx or epipharynx, or with a stratified squamous epithelium in the oropharynx and the meso or hypopharynx, which also covers the surface of the oral cavity and the oseopharynx. The lymphocyte frequency accumulate beneath the epithelium of the pharynx. Accumulation of lymph node tissue surrounding the opening of the digestive and respiratory passages form the what's called tonsils. The nasal cavity and the pharynx form the upper respiratory passages. As we see here in this figure, we have the oral cavity and the nasal cavity, and we move down the respiratory system. We see the epiglottis and the larynx and their cells. Now we move into the suitable slide. We have here the section of the respiratory region of the nasal cavity after the pigmentation. We have the inferior concha of the human and the structure which consists of the tissue with very different physical properties, like loose connective tissue and bone may easily get damaged during tissue preparation. In the operation when we prepare the slide for the microscope, we find a spot that where the layer form the epithelium to the bone appear intact. Identify the goblet cells and basal cells and ciliated cells in the epithelium. Now we have to look in the lamina propria. Depending on the exact location, you may see the connective tissue between the epithelium and the bone, or large spaces, either empty or filled with red blood cells, which represent the cavernous sinusoid or the glandular tissue, as we see here in the figure. We have this histological slide on the microscope. Now we move into another slide, which is a slide of the olfactory region of the nasal cavity, also pigmented, and we can now know how it is prepared. The nasal cavity olfactory region, we have in a human the olfactory epithelium lines the superior concha and the part of the nasal septum. The bony structure beneath the epithelium form an irregular surface, which increase the turbulence in the air passing them, thereby the chance that ordinate come in contact with the olfactory epithelium. In the macrosomatic animals like the rat, the olfactory epithelium also cover the middle concha and the surface of the considerably more enlarged than in human. The olfactory epithelium is formed by olfactory cells, syncytial cells, and basal cells. Basal cells can be identified by the location, and cystonicular cells are preferentially located in the superficial cell tier and the epithelium, but are difficult to distinguish from the olfactory cells in the preparation. We see here the draw of the olfactory epithelium and the underlying lamina propria at a high magnification. The feature including the drawing, we here see the larynx and the trachea and the bronchi of bronchioles from the lower passages of the respiratory system. And now we move into the larynx. The larynx connects the pharynx to the trachea, and the vocal cords of the larynx control the airflow and allow the production of sound. The vocal folds are lined by stratified squamous epithelium and contain the muscle, which is striated and skeletal, and ligament needed to control the tension of the vocal folds. Larynx is supported by a set of complexly shaped cartilage. We have the trachea. The trachea is a fairly short tube, about 10 to 12 centimeters, with a diameter of 2 centimeters. Epithelium and mucosa and submucosa. The trachea is lined by respiratory epithelium, and the number of goblet cells is variable and depending on the physical and chemical irritation of the epithelium, which increase goblet cells number. Prolonged intense irritation of the epithelium may lead to its transformation to a stratified squamous epithelium, which is called squamous metabolism. In addition, the stable of the basal cells, ciliated cells, and goblet cells, the respiratory epithelium also contain brush cells and endocrine cells, which are small granule cells, function not clear, and it also has serous cell, and the epithelium and the underlying lamina propria are called the mucosa, and the lamina propria consists of the loose connective tissue. with many elastic fibers which condense at the deep border of the lamina propria to form the elastic membrane. This elastic membrane forms the border between the mucosa and the connective tissue below it, which is called the submucosa. The mucosa serous gland in the submucosa supplement the secretion of the cells in the epithelium. And the submucosa end with the precondyrium of the trachea cartilage. The tracheal cartilage. The trachea is stabilized by 16 to 20 C-shaped cartilage, which is the hyaline cartilage, and the free dorsal end of the cartilage are connected by bands of smooth muscle, which is called the tracheal muscles. And the connected by band of smooth muscles, we have also longitudinal, collagenous, and elastic connective tissue fibers, which is called the annular ligament, line the individual cartilage and allow both of the lengthening and shortening of the trachea, for example, during swallowing or movement of the neck. They are inseparable from the fibers of the precondyrium. The trachea cartilage may ossify with age, and the cartilage, annular ligament, and the tracheal muscles form the skeleton of the trachea, which sometimes is referred to as the tinea fibromusculocartilage genia. If you want to impress someone with the term, make sure that you can pronounce it and you can spell it. The trachea bifurculate and give rise to the main bronchi. Their histological structure corresponds largely to that of the trachea. Here we have the parts of the respiratory system, and we see here the capillaries and the alveoli and the trachea and the main bronchioles. Now we move into the suitable slide. We have here the slide of the trachea. In the trachea, you should be able to identify the following structure: the respiratory epithelium, the basement membrane, and the submucosal gland, and the precondyrium, and the tracheal cartilage and the muscles. And one can present different appearance of the connective tissue immediately below the epithelium and the connective tissue surrounding the submucosa gland. But the elastic lamina forming the border between the mucosa and the submucosa is not visible in the staining process. We here see the draw and assemble of all the main features of the trachea in one drawing and of a segment of the trachea with the main feature labeled. We see it in this slide. Now we move into the conductive structure in the lung. We have the bronchi. The bronchi in the lungs, we found in the lungs the last segment of the conductive portion of the respiratory system, which is the main bronchi, divided into lobar bronchi, and which are turn give rise to the segment bronchi. The latter supply of the bronchopulmonary segment of the lungs, which is the bronchial branches, are accompanied with branches of the pulmonary artery, nerve, and lymph vessels. This structure usually travel in the intra-segmented and interlobal sheets of the connective tissue. Conductive structure of a size down to 1 mm are termed bronchi. Smallest one are called bronchioles. Aside from their different sizes, bronchi are characterized by the presence of the glands and the supporting cartilage. The cartilage supporting the bronchi is typically found in several small pieces in the histological structure of the epithelium, and the underlying connective tissue of the bronchi corresponds largely to that of the trachea and the main bronchi. In addition, the bronchi are surrounded by a layer of smooth muscle which is located between the cartilage and the epithelium. The bronchioles are the terminal segment of the conductive portion. At the transition from the bronchi to the bronchioles, the epithelium changes to a ciliated columnar epithelium, but most of the cell type found in the epithelium of other parts of the conductive portion are still present, gland and cartilage are absent, and the layer of smooth muscle is relatively thicker than in the bronchi. Now we move into the respiratory structure in the lungs. The bronchi divide into the respiratory bronchioles. So the bronchioles divide into respiratory bronchioles, which are the first structures that belong to the respiratory portion of the respiratory system. Small outpunching of the wall of the respiratory bronchioles form the alveoli. The site of the gas exchange and the number of the alveoli increases as the respiratory bronchioles continue to divide. They terminate in alveolar duct. The walls of the alveolar ducts consist entirely of alveoli. Histological structure of the alveoli. The alveoli is the wall of the alveoli is formed by a thin sheet about 2 micrometer of tissue separating two neighboring alveoli. The sheet is formed by epithelial cells, and the interventing connective tissue collagenous are few and fine. Reticular and elastic fiber are present, and between the connective tissue fibers we found the dense and anastomosing network of plummentary capillaries. The wall of the capillaries are in direct contact with the epithelial lining of the alveoli. The basal lamina of the epithelial and the endothelium may actually fuse. Neighboring alveoli may be connected to each other by small alveolar pores. The epithelium of the alveoli is formed by two types of cells, the alveoli type 1 and type 2. The type 1 are small alveolar cells, or type 1 pneumonocytes are extremely flattened, and the cells may be as thin as 0.05 micrometer and form about the bulk of 25 of the surface of the alveolar wall, and the shape of the cell is very complex, and they may actually form part of the epithelium by both faces and of the alveolar wall. And the type 2 are larger alveoli cells, or type 2 pneumonocytes are irregular, sometimes cubital shaped. They form a small bulge on the alveolar wall, and the type 2 alveoli contain a large number of granules called cytosomes, which consist of precursor and to promontory surfactants, a mixture of phospholipids which keep the surface tension in the alveoli low. There are just above many type 2 as the type 1 cells. Their small contribution to the alveoli area is explained by their shape. Cilia are absent from the alveoli epithelium and cannot help to remove the particle matter which continuously enter the alveoli with the inspired air. The alveolar macrophage take care of this job. They margin freely over the alveolar epithelium and ingest the particle matters toward the end of their lifespan. They margin either toward the bronchioles, where they enter the mucous lining of the epithelium by finally discharging into the pharynx, or they enter the connective tissue septa of the lung. Here we have a histological slide of the lung of the human. You should be able to find the last bronchioles, alveoli duct, and alveoli in the section. The respiratory bronchi should be present but may require some time to find. Note that the bronchioles are usually accompanied by a vessel, a branch of the pulmonary artery. Interlobular connective tissue is also present and may be identified by holding the slide against the light. It is represented by continuous and fairly saturated streaks of the tissue visible without the microscope. Have a look at the bronchioli. Here we see the two figures, or the two slides. We see the part of the tissue at low magnification, including the alveoli duct and the bronchioles of the respiratory bronchi in the drawing. We see here in this lung we see the alveolar duct and the alveolus and another alveolus, and we see here the bronchioli and the smooth muscles surrounding it and the connective tissue. And this is the end of our report. Here we have the references and